Yeah, I'm audible. Yeah. Can you hear me?
I can hear you. How are you, man?
Yeah, I'm okay. I just came to US just about 1 month back.
Right.
California.
So, first of all, sorry for the delay. Okay.
Mm.
Just allow me 1 minute.
Yes.
Do let me know once my screen is visible to you. Okay.
Yeah.
So, what's up? What's going up?
Yeah, it's good. Yeah, you have CC Enterprise, Python,
So,
Nexus,
currently, you are working for which organization now?
United Health Group.
Okay. So, are you aware about Nexus or no?
Yeah, Nexus, I'm aware. I'm aware about VPC, VDD, VEX, VXLAN.
Okay. So, if I am not
What?
wrong,
Yeah, go ahead.
you today you just only wanted to see like how VPC need to be get configured, right?
Yeah, VPC. Yeah. What is I have thing only on VPC. What I wanted to learn was, you have the Nexus 9K or the 5K, okay,
Mm-hmm.
and then you have, let's say, if we have, say, in my organization, they're going to have 5 line cards. One is 3 for copper and 2 for fiber. So the servers is connected to the HP switches, okay, and now they're going to replace the HP switches, the Nexus switches, and they're going to connect the servers directly to the line cards, okay. Huh?
Right.
I know that the downstream device they use a trunk link. If it is a 5K or a switch, they use a trunk, switch port mode trunk. But in servers, they use access mode, right? That's the only thing I wanted to know about the configuration.
No, why? Server can be also trunk port.
So the configuration, I just wanted to go there. Let's say you have 7 servers or 8.
Your voice is breaking. I
The
am not able to hear you properly. Can you come closer to the mic and speak again?
that kind of configuration. Okay, hold on a second. Can you hear me now?
Yeah. Tell me.
Can you hear me?
Yes. Go ahead.
Okay. So yeah. So you have the servers connect the line card. That configuration I wanted to know from you.
Hmm. Okay. So
Yeah.
I tried to create a topology for you. Okay. I hope you are able to see
Okay.
my screen. Do you?
Yes, I can see your screen. Yeah.
So here, if you see, we have next two Nexus switches over here. And these two devices,
Mm-hmm.
below devices, you can treat them
Mm-hmm.
as server or maybe HPC or
Mm.
whatever you wanted to treat. Okay. So
Okay.
basically, we can say these
You
are,
recording this?
yes,
Are you recording?
yes.
Yeah. Okay.
These are downstream devices.
Yeah.
Okay. So
Mm.
we will be gonna start with this topology. Fine.
Okay. Okay.
Now,
So the downstream device could be a switch, could be anything, right? Could be a firewall, could be anything. Downstream device, right?
yep.
5K,
Yes, it can be
right?
layer 3, it can be layered. So I am just
Okay.
writing down over here so that you can refer these notes later on. Okay. So what I am telling, these are your Nexus switches, right? On the Nexus switches, you need to create a VPC. And beneath it, there can be
Okay.
servers.
Mm-hmm.
There can be one server,
What is
there
the
can
website again? Yeah.
sorry, can you
Mm.
repeat what you are telling? Rishi, are you able to hear me?
Mm. Yeah. I can hear you. I can hear you. Can you hear
Okay.
me?
Yes, I can.
Yeah.
So
Okay.
what I was saying, these
Uh,
downstream will get connected to your upper
so
parent switches.
yeah.
Okay. So bit like this. But
Mm.
since it is a VPC
Mm.
thing, your Logical topology would be like this. It won't be able to understand that there are two devices or single devices. For this, it will be a single device as appeared. Okay?
Yeah.
That is the whole crux of the story. For the same, we need to create a something named as peer keep alive link.
Keep alive, yeah. And that I know, yeah.
Peer keep alive link, you can create it point to point. Okay? You can create it point to point, and there are multiple ways. Can you just let me know quickly so that we can check over here?
Yeah, keep alive could be management interface, routed interface, or SVIs.
Yes. So in
VPC
our
domain. Okay,
in
so
our
VPC
topology,
domain,
yep.
VPC
In our
domain, peer
topology,
different keep alive destination,
use
source, that's it.
okay. Give me a minute. In our topology,
Yeah,
we will be using over the management. One thing.
yeah, yeah,
Second
yeah.
thing, we will be using something named
Yes.
as peer link.
Yeah.
Okay, peer link. So peer link we are creating with two of the interfaces, and we will bundle them in a port channel. Is it fine?
Yeah. Yep.
So far, any issue with this topology?
No problem.
No problem. Let's go ahead and configure this first of all, and then we will configure another downstream device. Okay. For the
Yeah.
same,
I want to know how the server is connected to the parent switch and the configuration for that.
I'm just showing you. Okay. This is in our topology. This is NXOS 3. Okay. In our topology, this is NXOS 4. And this is my downstream device 1. So I am just booting them up one by one. That is already booted. Okay. Let me just make them on.
Okay. Okay.
So currently there is no configuration. Okay. It's blank.
Okay.
Just
Yeah.
blank thing. So let me open these three devices, whatever I showed you in the picture. Okay, NXOS 3, NXOS 4, and DSD 5. Okay, this is DSD 5 in our topology. So let me just write down the word DSD 5. Fine. So let's go ahead and bring these devices. This is DSD 5. Okay, then I have NXOS 4, and the last device is NXOS 3.
3. Yeah.
Okay. Now, NXOS 3 we will be gonna start with. So let me just put enter. Okay, it's booting up or what?
Booting up, I guess.
Yeah, maybe it's booting up. Or DSD5 is up. So IP interface brief. Okay, DSD5 is up. Let's see with NXOS 3. Or quickly let me, reboot them so that we are not wasting any time. We will just boot up only those devices which we need. Rest all the devices we can just make them shut down. Let me take a refresh. So by this way, you would be able to understand how our topology will work. Okay.
Okay.
Getting my point?
Yeah.
What happened with this? It's not good. Okay. Here we go. So you also get stopped. Let me start this and start these two devices. Let me see. Okay. Either it is booting up now. Or fine. It's booting up.
Okay.
Here also, if we see, it's also booting. Okay.
Okay.
It will take a minute or two. Don't worry about that.
Okay. So using a management interface for the keep alive then, right?
So here, if you see in our topology, It is same. Actually, I don't want to disclose whole of the topology and make you panic. I'm just showing you only one part of our topology, which is bit like
Okay.
this. Then
Okay.
later on, I will keep on increasing this diagram. Okay.
Okay.
And we will
Okay.
jump on the same topology, whatever I am showing you on the lab. Okay. For
Sure.
now, only we are just discussing about the peer keep alive link, peer link, and the downstream devices. Now,
Okay.
on the downstream devices, here we will create a port channel. So these two interfaces will be the part of port channel. Okay. And these things are named as member ports. Member ports. This is also a member port. Meanwhile, the device is coming up. Can you tell me which device will be active and which device will be standby in this case? And is there any active or standby scenario appears also in case of Nexus devices or no?
Nexus is active and standby. You cannot have two active and active, right? You can't split pin scenario.
So let me tell you, in Nexus, it is always active and active for the data plane.
Okay.
Please be remembering. Okay. For data plane, your data can go to any of the switch. Both are always working as active. It is quite different from your VSS or other previous virtual, port channel technologies. But if we come to the control plane, okay, if we come to the control plane, because VPC is which layer? Can you tell me? VPC is which layer?
Layer 3.
No, it's pure layer 2. Okay. VPC is a layer 2 thing. So if you are talking about BPDUs, if you are talking about other control plane packets like R packet or maybe BPDU packet, so for the same, we have active and standby. It is very important. You need to understand. Okay. This is really a very, very important thing. So you have two devices, Nexus 1. You have Nexus 2. Okay, Nexus 2. There is a peer link. There is a peer keep alive link. And below is your one device, what I was talking about. This is your downstream device. This downstream device can send data traffic over here and can send data traffic over here. So how this downstream device will judge that where I should send the traffic? Any clue?
Goes to the link.
Sorry?
It goes to traffic, goes to the peer link.
Your voice is not clear, but okay, let me tell you. So there is in the port channel, there is a hashing algorithm. Okay, hashing algorithm. Depending upon that hashing algorithm, data can send to one of the two devices, and it's perfectly fine because in case of data, it is an active and active scenario. That's cool. But if I will talk about, let us say, because I told you VPC is a layer 2 device technologies. Okay. So if you have Nexus 1, if you have Nexus 2, again you have peer link, you have peer keep alive link, you have two lower member ports going to the different devices. There is your DSD. But now if BPDU packet need to send, I am now talking about control plane. So if BPDU need to send, this BPDU will gonna send only on the active device, not on the standby. Okay.
Yes.
How this active standby roles will be get selected? Any idea? Again, there is
You have a
two
role,
things.
right?
There is role
VPC role.
priority. There is role
Primary and
priority
secondary. Primary and secondary.
and MAC address. So this will be primary and secondary. Correct. Roles would be primary. Okay, let me write down the correct term. Primary and secondary. Okay.
Yeah. So
it will be primary or secondary. So who will be primary? The one who will win in this. Lower is better. Okay. Whosoever is the lower, that will win the race. But let me tell you one more thing. Very interesting. In case of Nexus, these roles are non-preempt. Okay. These roles are non-preempt. What does it mean? Non-preemptive. Have you heard about this term, non-preempt?
No,
In
no.
HSRP especially. What is this?
Preempt can come. Yeah, preempt. Yeah. In SSRP comes a preempt. Yeah.
In HSRP it is preempt. Here it is non-preempt. It means if it become primary, it will become the primary only. Okay, let us say Nexus 1 is down and second is getting primary. Now Nexus 1 is booting up and it comes in fledged. It will be in the secondary role also. Only it won't take the primary role back. That is named as non-prim. Okay, these are non-prim. In the failover scenarios, there are a lot of things which come into the picture. But let's first, talk about our lab topology. Then we will go for those things.
Yeah.
If
So it's
time
always primary and
allows.
secondary. Okay. Always primary and secondary. You can't have
I
primary,
will show
primary.
you. Don't worry. I will show you. Okay.
Yeah.
Let me see. Either it is booted up. So still it's booting up. Huh? Okay. Maybe 1 or 2 more minutes it will take. And then it's a heavy device.
See, in the thing, we only have two roles. Which one is primary and secondary. We cannot have primary and primary. If you have primary and primary, it's going to have split brain scenario, right?
With respect to the control packet only. With respect to the data packet, both are active. You need to understand that. So if you talk about data, data can go here, data can go here. Not an issue. Okay. Depending upon your, that is what I am mentioning here. Data plane will be active. Control plane will be primary and secondary. Okay.
Okay.
Got this point, Rishi?
Yeah, I got it.
Yeah. So these are still in the booting phase. Very heavy devices actually. Okay. So we are using Nexus 9K for our lab. Okay. These are the 9K devices and it takes a good time to get. It's all. I tried to boot it earlier, but maybe something happened. It doesn't, came. Let me ask meanwhile one more question. So let us say we have Nexus 1K, we have Nexus 2. Okay. And here is your downstream device.
Server.
Yeah. Server. So this server is connected to both of these devices, and here you are creating a port channel. Then there is two links connected over here. By the way, what is the minimum bandwidth which we required for the peer link? Any idea?
10 GB.
10. Yes, 10. And what is the minimum like bandwidth for the peer keep alive link? 1 gig. Okay.
1 gig.
It is 1 gig. So, okay, tell me one thing. If our peer keep alive link is down, what should be the case? Any idea?
Nothing will happen. Nothing will happen. It keeps on operating.
Very
No
good.
impact.
If my peer link is down, then
Then the primary switch will instruct a secondary switch to shut down all its member ports, and then
yes,
the traffic will continue to go to the primary
and the
without any interruption.
SPI also.
Yeah.
Right. That
Yeah.
is great. And what
Okay.
happened if my member ports will down? Everything is up, but this member port is down. Let us say this member port is down. Then what happened?
Then it will go through another member port.
Right, because data plane is not an issue.
Yeah.
Right. Now, let me tell you one scenario.
And then if you have both keep alive and peerling down, then it's a split brain scenario.
No, that's fine. That's fine. Now I am giving you a very, very, very important scenario. Okay. Please try to understand it very properly. Member port is down. Peer keep alive link is up. Peer link is up. This is my primary. This is my secondary. Primary is down. Member port is down, which means control packet, it cannot send. What should be the case now? Are you getting that question?
Yeah.
Now tell
It'll
me.
go through the secondary link. It'll go through the secondary link.
No. How it can go? I told you that control plane packet control plane packet will always go to the primary, not to the secondary. So it will go to the primary, but primary is now down. Member port of primary is down now. So what could be the case? How it should behave now?
Member port is done. You have to go to the secondary member port, right? That's what I think.
Okay, let me tell you. In these scenarios, what happened is we have some of the features or enhancement, I will say. Your primary Nexus switch will give the instruction over these links and tell your secondary, I cannot handle the control plane packet now. Okay, you become the primary. So it will become something named as operational primary. So that
split plane scenario. Split plane scenario. You're talking about split plane scenario, right?
Split brain is something else. Split brain, like when your peer keep alive and peer link, both will get down. Getting my point?
Okay.
So that is split brain. That is a little bit different scenario. Okay. Here, only member port is down. Peer keep alive link is also up. Peer link is also. Are you with me? So there are lot of scenarios which happens. Similarly, if I don't know if you have gone through such of the environment or no. Let us say there again you have Nexus 1, you have Nexus 2. Okay. And there is a router L3, okay, which is acting as your downstream device. Okay. And below is also you have, let us say, some DSD. Okay. But this is L3 out maybe. Okay. So what happened is you have a peer keep library, you have the peer, right? That is how. And you will create a port channel over here, port channel over here, right? Now, let us say if this link got fails, all the member port and everything will be down over here, right?
Yes, yes.
As you told. And once this link comes up, this will also come up, right? But when we talk about L3 protocol table, to building them up, it takes some time. But these member port will come up then and there whenever the peer link is up. So it can create a black hole over here if some traffic is coming for the momentary basis. Getting my point? So then there also we need to configure couple of the options. Are you aware which option?
Member ports?
Okay, let me tell you. You just try to see the recommended stuff like peer switch, peer gateway, peer router, okay, IP ARP sync, okay, delay restore. So these all features are really very, very important. Okay. So in this case, peer gateway is one which we need to get installed. Like it's only a one command, but you need to understand the concept, like how it will be done. Are you getting my point?
Okay.
Right. So what happened? Why these are taking so much time? They don't take such a huge time. Allow me a minute. Let me reboot the server. Complete server I need to do.
Okay.
Because it's really taking some unusual time. I'm really sorry for that. I don't know why this is happening. But I hope you are getting a lot of interesting facts about the Nexus and the VPC. Yeah. right?
Can you go through a little bit about pure switch and pure gateway and delay restore?
Sorry.
Can you go through pure switch, pure gateway, and delay restore?
Okay, the enhancement you mean to say, yeah?
Yeah.
Why not? I can. I can. So these are the features, first of all. Okay.
Mm.
Let's talk about peer gateway.
Mm-hmm.
Okay. It is very important feature which will come into the picture when you have L3 integration with your VPC. Okay. This is a recommended thing that you need to put these kind of stuff over there. Okay. So that your peer link usage can be less. How?
Mm-hmm.
I am telling you. Okay. So
Mm-hmm.
again, let's create a diagram to understand it. There is a primary device, there is a secondary
Secondary.
device. Okay, with respect to the control plane, please. Data plane, both are active, always. And let us say they will go outside from here, and beneath, let us create a router or something which is acting as a DSD.
DSD.
Okay, here also DSD, here also DSD. Both way DSD is there, right? Now, how many lookups will happen here? There will be two type of lookups. One is layer 3 lookup, one is layer 2 lookup, right? So layer 3 lookup can be used to provide who would be my gateway, and depending upon that, maybe exit interface need to find out. But actually, exit interface, who will decide? Layer 2 will decide. Are you with me? Getting my point? So what happened is, in case of your like link failure, okay, it might
Peer link.
happen. Yeah, in case of link failure, it might happen that your traffic is moving like this, okay, or vice versa, like this. So there, what you are doing, you are overutilizing your peer link. It can be oversubscribed. Okay. Since it is it is not, suggested ever that you should be using your peer link. Okay. For the data traffic. For the data traffic. So that is the reason we use peer gateway. When we will use peer gateway, we can save the oversubscription of peer link. Just allow me a minute. Let me check if my lab is up. I just rebooted the server. Okay. Finally, now the booting is really very, very fast. If you see, that is one, right? So,
Okay, so
I,
peer gateway is what? So your peer link is oversubscribed. So you have two bundling links in the peer link, right?
so
Two
let me show
physical
you.
links.
Don't worry, don't worry. If you wanted to go through the actual, definition, peer gateway in Cisco VPC. Okay, let me go through the actual maybe definition so that you can understand it. Okay, can you see this? The same diagram what I was talking about. Oops, no. Let me find out some peer gateway only so that I can make you understand the actual. Not this as well. Some good link. Maybe this one. Right, here you. So if you see, it is talking about the peer gateway and peer gateway is only a single command. Let me show you where he is putting the command. See, under the VPC domain, you just need to write down peer gateway. Okay, 3 commands are very important which starts with the peer. I will show you all those commands. Okay, in our lab also. So here, let's see. Have a peer gateway enabled for VPC VLAN. Oh, by the way, what is VPC VLAN? And what is non-VPC VLAN? Are you aware about this terminology? Yes or no, please?
VPC, you talking about member ports?
No, VPC VLAN I am talking about.
Member ports.
Are you aware about VPC VLAN?
No, I don't.
It's all right. Let me tell you. Because these are the very important terminologies. Okay, you need to aware about. See, what happened is, we have Nexus port 1. We have Nexus switch 2. Sorry, not port. Nexus switch 1 and Nexus switch 2. Here is our server. We are configuring like this. There can be multiple servers, right? Here also a port channel, here also a port channel. Again, for peer link, you have a port channel. Again, you have a peer keep alive. Now, let us say this server is running on 10, 20, 30 VLAN. This is running on 40, 50, 60 VLAN. Okay. And there is some device which is named as orphan device. I hope you are aware about it.
Yeah, orphan device. Yes.
Right. Let us say it is 100 VLAN. Okay. So what happened is, on your VPC, you configured 10, 20, 30, 40, 50, and 60 VLAN. For 100, you can create another port channel, which is not a peer link. It's another port channel you can create, and you can just send the 100 traffic over there, so that some devices which are wanted to go from here to there, A to B device, if they wanted to communicate on the 100, they will not utilize your peer link. Okay, they will go through the another port channel. Getting my point? So this is named as non-VPC VLAN. And these devices which are utilizing your VLANs for the VPC related are named as VPC VLAN. Getting my point?
I got VPC VLAN goes to the peer link.
So VPC, yeah, why not? Because it's okay. Here you go. Finally, that is what I was thinking. Like, why it's taking so much time? Okay, Nexus 3 up. Maybe some issue. These are the logical devices. So these 2 devices are up and running well, right? Now let's see DSD. What about my DSD? Maybe I close the wrong session. Let me open the DSD again. I'm just coming to that point. Okay, give me a minute. Okay. Let me check about my DSD. What happened with my DSD now? Oh, it's here, alive. Fine. Okay. Now let's come back over here on the summary portion what I was discussing you. So having a peer gateway enabled for the VPC VLAN, only for the VPC VLAN. Avoid issue due to storage servers of some vendors. Disable peer gateway for a VLAN SVI that VLAN is down for the VPC pair. Avoid to drop some inter-VLAN routing. See, long story short. Okay, it's also not a good link. I will give you some good link. Okay, I have some of the documents. I will give you a good link. Long story short, when there is a L3 kind of communication, they are not aware about their each other gateway. So if it has a gateway here or here, okay, and data traffic is coming over here, but ultimately the gateway need to go from primary device. So it has to travel from peer link. So from peer link, it will send to the primary, then primary, it will go outside. But if we will
Out to the
put,
internet, out to the internet, right?
yes, wherever, okay, not internet, maybe any device, any layer 3 device, we can say. Now,
Mm.
if we issue the peer gateway, they will aware about their own, both of their gateway. So it is aware that, okay, the gateway is here. It won't utilize the peer link, but directly it can send the traffic if the traffic is coming to the secondary device. By using this, your peer link usage will be less for the data traffic, and that is what Cisco is recommending every time. Is it fine?
Okay. So the traffic is not going through peer link. It goes to gateway.
Data traffic should not go to the peer link for sure. Okay.
Mhm.
Now let's come back to our lab topology and create it because we have only few minutes left. Okay. We annex 3, annex 4, and DSD5. This is my
Mhm.
lab topology. I need to create a VPC over here, and I need to show you how VPC work. Okay. So I am creating a like VPC domain on the top over here, maybe VPC domain 100. Okay. And here I
Mhm.
will create some VPC number, maybe VPC 5 or something we can create. So let's not take much
Mhm.
time. Go to the Nexus device 3. I am going in the config uh, T and saying host name is NX3. Okay. In
Mhm.
NX3, I need to enable the feature. First of all, you need to enable the feature like feature VPC, and the
Yeah,
second
yeah, yeah.
feature,
Oh, no, 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 I know this. I know this. Yeah, yeah.
fine, LACP,
LACP.
right?
Mm.
So these two features you need to enable, which I did. Second thing is you need to go to your management port. Okay. In
Mhm.
the management port, you need to put some of the IP. So if you will see our lab, there is 10, 10, 10 range. Because it is 3, I will use 3 as an IP address. So IP address 10.10.10.3
Mhm.
255.255.255.0. And always
Mhm.
put no shut whenever you are doing any work over here. Okay. And show IP interface brief. So
Mhm.
uh, what happened? Okay. Here you go.
Mhm.
We have show interface brief. If we see, okay, we have the IP address there. Same thing. Let me
Mhm.
go for the Nexus for
Mhm.
conf t. Okay. Again, I will say host name annex 4.
Mhm.
Then feature. Feature. Very
Mhm.
first is VPC. Then feature. Second feature is LACP. Okay.
Mhm.
Then
Mhm.
interface management O, and here IP address, because it is 4, I will use 4 in the last 255.255.255.0. No shut. Okay.
Mhm.
And let me do copy run start so that I can save this configuration. Now let me
Mhm.
ask you 10.10.10.3, if I will ping, will it give answer yes or no?
You got to do way of management.
Very good. It will be having a VRF of management.
Management.
Okay, so we need to do like that. And here you go. We have the management port accessibility. One thing is
Mm.
done. Any questions so far?
No problem. Go ahead.
No problem. Now let's go to the Nexus 3 again. I'm going to the config T, and
Mm.
I am now going for the VPC. As I told you, I will create a VPC domain, and I'm taking the domain ID 100. Similarly, going over here, config T and VPC. Okay. Under the VPC, I need to say which domain 100. It is bit
100.
like your BGP, that
Yeah. Yeah.
if you are doing router BGP something, you cannot put any other AS. Similarly, domain will be one on. Getting my point?
Mm. Yeah. Yeah.
Here on the 4, I need to say peer. And can you see these 3 devices starting with the peer?
Mhm.
These are really very
Mhm.
important. You need to learn them. But first, let me go with peer keep alive. Peer keep alive destination for my 4 will be 10.10.10.3. Same way for 3. If I will go over here, the destination should be 4.
4.
Any doubts so far?
No problem.
Okay. So now where I am in the domain. Let me put exit. Okay. Now what I need to do, I need to create, if you see here, I have created this thing. Okay. These all things I have created. Now
Keep live created.
I am
Domain
going,
name created, keep live created.
going for this.
Peer link.
I will create a port channel 100 over this side and port channel 100 over this side. Okay. Let's go. So on 3, first let me do on 3. Where is 3? Give me a minute, please. 3. Okay. Interface port channel 100. Right? I am saying switch port mode trunk. Okay. Then I am issuing a command VPC peer link. Getting my point?
Yeah, I got it. Okay. I know this. I've done this before. Yeah.
Fine. Then I'm saying no shut. Okay.
Yeah.
And coming out of it. Similarly, first let me create a port channel over here. Interface port channel 100. Okay. Switch port mode trunk, and then VPC peer link.
Okay, good.
Okay. And
we can proceed.
Both sides I created port channel 100.
Okay.
One thing.
Okay. Now, if you go to show VPC, you will get the peer cable level up and peer link up now. Okay.
Wait for a while. VPC. We will let us configure the completely, then we will see. Okay. So far, if you check over here, we have created port channel 100, but these ports should be the part of port channel 100, right?
100, yeah.
So now I need to configure on these ports, and it should be the part of port channel 100. Getting my point? Yes or no?
Yeah. PPC member port.
Right. Let's go over here. Okay. And let me exit out of this. Now, what are my ports numbers? Sorry. It's 1 by 1 and 1 by 2 both sides.
So, what are the ports again? Sorry, can you see the ports?
Yeah. Let me show you. The ports are 1 by 1 and 1 by 2. Okay.
That is a peer link, right?
As a peer link, which I will be gonna use. So interface is 1 by 1 to 1 by 2, right? Are you getting my point?
Yeah.
So channel group 100.
Yeah, I understand that. Yeah, let's go for the member ports. Let's see the configuration of the member ports.
Yeah. Force mode active is the command to actively make them the part of it. And switch port mode trunk is the another configuration. Similarly, let me go over here. Okay. And let me just run this command again.
Yep.
Okay. No shut for sure. Here also no shut, and here also and. So VPC is configured. So far I have configured the VPC.
Keep level configured. Peer link is configured. If you push show VPC, it will come up now. Okay.
Let me show you. So show VPC. If you see, you can see peer adjacency form, peer link is form. But if you see, number of VPC configured are
0.
Why?
Because we're not configuring the VPC ports, member ports.
We haven't created any of the VPC. And if you see below that, there is peer gateway. That is currently disabled. Can you see that?
Yeah, I got it.
Right. And delay restore. Okay. So there are a lot of options. Probably I won't be touching now. But see the role. VPC role is prime. If you go to the Nexus N4K now and run the same command, show VPC. Okay. Here the role is secondary. Again, domain is 100, peer status up, everything is there. Port channel is also
Okay.
fine.
So I want to ask you, in terms of the data plane, both 3 and 4 are active and active, but in terms of control
Active,
plane, one is
active.
primary and secondary, right?
Yes, yes, yes. And if
Okay,
you
got it.
see here
In terms
one
of
command,
data plane,
show,
in terms of data plane, both will be active, but in terms of control
right.
plane, one will be primary,
If you
Nexus 3
see
will be
show
primary, Nexus
VPC
4 will be
role,
secondary.
if you see show VPC role,
Yeah.
can you tell me only one thing? What is the difference between this and this? It is very important question. That is the reason I am asking.
Mm-hmm.
For today's lab, it is very important question. What is the difference between system MAC, VPC system MAC, and VPC local MAC? No idea? Fine. I will gonna
System
talk.
MAC, is that the MAC into the switch?
So I will explain. Don't worry.
Mm-hmm.
See, what happened is when you create a VPC, as I told you, for your downstream device, it will appear as a logical
One
one
logical
device,
switch, yeah. Yeah, one device, yeah.
right? So it means logical device should have some MAC address. Are you getting my point? So VPC, this device has some MAC, let us say 3333. This device has some MAC, burnt in MAC address 444. But as in VPC, they create a common MAC, let us say AAAA. So here, for the lower device, MAC address, what it will see is AAAA. Are you with me?
Okay. Okay.
So
Okay. So if you
I
have a
will tell
logical
you
connection, it will become a
again,
MAC address will be A, is it?
just give me a minute. I am explaining.
Okay.
So if I will show you again, okay, here on this device, you can see there is a VPC system MAC. This is a virtual. And if you see, this is a local that is burnt in access MAC address of NX3. If you
Okay.
see, there should be a system of the second also. That's fine. So I hope you are able to understand it.
Yes, 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 yes.
This is burnt in access for your NX4. Getting this point?
Okay.
Yes or no,
I got it.
please?
Yes, system MAC is a logical MAC address.
Right. So that is how your lower device will able to recognize upper device with this virtual MAC. And how this virtual MAC form? Depending upon your VPC domain. If your VPC domain is 100, so it is creating 64 in the hexa. Let us see. Okay. Give me a minute. Let me open a calculator. Actually, there are a lot of things, but it's all right. Can we convert into hex? Scientific. Is hex there? No. It's all right. Let's go to the internet directly. 100 to hex. Can you see? 64 in the last. So this 64 is built up from where? From your VPC domain. On the
100.
top, yeah. If it
100.
would be 10, then it should be a 0A. Okay?
Okay.
Getting my point?
Yes, yes, I got it.
Fine. Let's go ahead because we need to create this. So I am going on now lower device. Upper device done. Okay? VPC port, member port, I will be configuring in few minutes. Okay? But so far, I hope there should not be any doubt. If you have any question,
No
please.
doubt, no doubt, no doubt, no doubt. Go ahead.
Fine, fine. So now I am just creating, maybe you can create couple of the VLANs if you want. If you don't want, then fine. I am not creating the VLAN as of now. I just wanted to go for further configuration. Okay.
Okay.
So
okay.
Now what I need to do, I need to create a port channel. Okay. Port channel for what? Let us say this is my 5 device. I will create a port channel. Let us say port channel 5 over here, port channel 5 over here towards my downstream device. Are you getting my point?
Okay. The downstream device also will be part of port channel 5, right?
Right. So let me show you. Don't worry. Nexus 3. I am going to the config T. I am creating an port channel 5, no shut, and I am saying this is the part of VPC 5. Even if I will put VPC, only single VPC. So VPC ID will be brought up from the port channel number.
Yeah, it has to be the same as the port channel number, right? Yeah.
So whatever the port channel number is, it will take the same VPC ID. Okay? If I just write down VPC. But if I need to specify something, I can put. So I'm saying switch port, mode, trunk. Okay, I am just allowing everything, but you need to allow the specific VLAN, whatever required for our case. Okay, no shut I have issued, exit. Now, if I will go to the, I created a port channel. Now, on the ETH 1/5, because 1/5 is the one port. Okay, I need to make the part of VPC 5. So I need to go int ETH 1/5, right? I need to say channel group 5 ports mode active. Then switch port mode trunk, although it should pick up from there, but I am, what happened? Huh? Why not? Switch port. Okay, I will see. Let me just make the channel group. Okay, I have already done that. No shut, right? Let me see.
So how many ports you have for downstream devices? Just one port? Can you show me the diagram?
Can you repeat again?
How many ports? Okay,
only
so you
one.
have one port.
Only one this side. Only one this side. Next side, one. Okay. So as per our diagram, if you will see our diagram, this is ETH 1/5. This is ETH 1/6.
Okay, I got it. Thanks.
Okay. So I will be just configuring the same, because from here you can confuse. I write down over there. Okay.
Okay.
Now let us go to NX4 and X4 and do the same thing. Conft interface port channel 5. Okay. No shut VPC, because it will take VPC 5 from there. Switch port mode trunk, right? Interface it's 1/6 this side. I need to say channel group 5 ports mode active.
Okay.
And again I need to say no shut and copy. Please don't forget this. Copy run to startup configuration. So far,
what about the
doubt?
VPC? You don't put VPC? Okay, you can leave it already. Okay.
Any doubt so far?
Yeah, so VPC is already created. You don't have to put 5, right, for the VPC. It will take the port number of channel port number of 5.
Automatically it will take. Yes.
Okay. So you don't have to put like VPC 5 or whatever it is, right?
No, right? You need not to explicitly if you wanted to add. Now I am going to DSD5. Okay. I am going to DSD5 and I am making configuration over there. You need to understand it very closely so that you can able
this
to
is
understand.
One. See, you have the servers. Example, see,
this is
we
a
have
server.
About 7 to 8 servers.
This is a server.
I'll tell you what, Radhi sir. In our data center at California, we have about 7 to 8 physical servers, which the HP switches will be replaced by a Nexus switch, and you have 7 to 8 physical servers will be connected to the Nexus switch. That's the configuration I want to know. How do you do it downstream?
Good. So now, in your case, you just try to understand this is a server.
Yeah.
Now, server team, what need to do? You need to understand that. Server team need not to aware about VPC. One thing, VPC, you should be aware. Server team should not be aware. So this is a server. Yes. Server team will go to the conft. They will go to their interface range. In my case, interface is 0/0 and 0/1. Okay. So range is 0/0 to 0/1. So server team will go to their interface. One thing, they will make it as trunk switch port.
Shouldn't it be access port, sir? Because it's an end device, right?
Okay. Let me tell you that. Give me a minute.
Okay. Because as a downstream is a server. If a downstream is a switch, then you
wait a minute. I am telling. See what happened, Rishi. Maybe you haven't worked for the server. let us say it is an ESXi server.
VMware,
Okay.
VMware is the server. Yeah.
ESXi server has the inbuilt router or switch, maybe whatever you used to say, they have. And there are n number of VMs. These VMs can be part of 10, 20, 30, 40 VLAN. So if you will create this as from our NX3 and there is NX4, let us say like this. So if you will create this as access port, okay, access port, you can go with only one.
One VLAN.
Are you getting my point?
Yes,
So,
yes, I got it.
so it should be always a trunk. Is this part clear?
I got it. Because access VLAN carries traffic for only one VLAN, whereas trunking carries traffic for multiple VLANs, right?
Right. So let me go
It has to
again.
be a trunk. It has to be a trunk.
Yep. So let me go on my server, switch port,
DSD.
mode, trunk. DSD is what? Okay.
No trunk.
I need to say switch port, trunk, negotiation. Trunk, what was that command? Encapsulation. Not one queue. Then switch port, mode, trunk. Okay. Then I need to create a port channel here, right? I can just write down channel group. I can create any channel group, by the way. I am just taking 5, better for the troubleshooting, and saying mode active. It will create a port channel by its own. Are you getting my point?
Yes.
And WR, if I will make it bigger, and if I will show, it should be Ether channel, yeah? So Ether channel summary. Can you see? It's up.
Both the ports are up.
Both the ports are up. Are you with me?
Yeah.
Getting this point?
I got it.
Show spanning tree. You can see port channel 5 is there, right? And
hello?
Okay, fine. I'm just telling you, wait for a while. If you go over here, show port channel summary. Okay. Can you see? Hello?
Yeah.
Similarly, if I will write down show VPC, there should be a VPC 1 now. And if you go down, it is mentioning about the VPC status.
Okay. Can you go to port channel summary again? Sorry.
Okay. VPC summary.
Port channel summary.
Port channel summary. Okay. Show port channel summary. Yes.
Okay. So the. Okay, I got it. So the 100 is the peer link, right? Okay.
Right.
And 5 is the member ports. Okay, downstream devices. Okay.
So that is the whole story of your VPC DC.
Okay. Can you go to the downstream server? Downstream device, DSD, the server?
Right. Here you go.
And did you put VPC 5 there? Can you just...
No. That is what I am saying. You need not to put anything related to the VPC on the downstream. Downstream is not aware. So if I will show you show run interface, it's 1 by 1, okay? Or show run interface port channel 5, you can see very simple configuration I am putting over here. If you just see this interface, show run interface, it's 0 by 1, no VPC related configuration would be there. So your lower switch is not aware about VPC for sure. There is no configuration.
Okay, it's creating a trunk link of 5. That's it. Port channel 5. That's it. Okay.
Yes.
Okay. Can you go to show port of in-channel summary on the server?
Here.
On the server. On the server. On the DSD.
Okay. What I need to run?
Yeah. Show the channel summary.
Yes. Show Ether channel summary.
Okay, I got it. So the 0, okay, I got it. So the downstream devices DSD is 00 to Nexus 3 and 01 to Nexus 4.
So,
right?
Ideally, this is like this: NX3,
yeah,
NX4, and 4 downstream. Okay, DSD. One port is going here, one port is going here. This is a port channel.
5, port
So
channel 5.
it is, yeah, it's 0 by 0, it is 0 by 1.
Okay, and you can and you configure that as a trunk port.
It is 1 by 5, it's 1 by 6, and they are creating a VPC.
Yeah.
VPC
Yeah, pure link.
100 domain. Okay.
Right. Okay,
Fine.
okay.
I need to drop out now because I have some another session. Okay. So if needed, maybe we can schedule another sort of session and we can go ahead and we can check multiple of the things.
Okay, just 1 second. Okay, for the downstream device, you have what channel? Okay, I got it. So for each of the servers, you got to go and create a port channel for the upstream devices, right?
Yes, you need to.
Right?
Yes.
Right?
Yes.
Okay,
right.
so let's say you have 6 or 7. Can you show me on the diagram? Yeah.
I am creating a diagram for you, but again, I need to drop out within 2 to 3 minutes. Okay, please excuse me
but
for the
just show me the diagram. Yeah, just show me the
But
diagram. Yeah.
no,
Yeah.
I am creating a new so that you can able to understand. I got your
Like
query.
if you have 6, 7 servers. Yeah.
I got your query. Don't worry. I am creating that. Let us say you have 4 servers. Okay. The all 4 servers will have such kind of connectivity. And from the server level, this will be the port channel, this will be the port channel, this will be the port channel, and this will be the port channel. Okay. And on the Nexus level, let us say this is server number 3, this is server 4, this is server 5, this is server 6. Here you will create VPC 3. Here you will create VPC 4, VPC 5, and VPC 6 respectively. Similarly, VPC 3, VPC 4, VPC 5, and VPC 6 respectively. Okay. For sure, here you should have a peer link, and here you should have a peer keep alive link. Okay. And VPC domain. Maybe I am taking 100. That is how your configuration will be.
Okay, and you just create the port channel on the servers.
Lower side. Yes, on the lower side, you can create, let us say, port channel 3. Okay. Port channel 4, port channel 5, and port channel 6. Again, it can be any number, but I am just giving you an example.
No, giving the number. Just giving the number. Yeah. Okay, and that becomes a trunk link, right?
Yeah.
DST will become a trunk link.
Yeah.
Okay?
Yeah.
And upstream switches will become a trunk link, but we're just giving a VPC number for that. That's it.
Yes.
Okay. So everything will become a trunk link. Okay. Between server 3 to Nexus 3, Nexus 4 will be a trunk link of port channel 3. 4 will go to Nexus 3, Nexus 4, the port 4. 5 will go to Nexus 4, port channel of 5. And 6 will go to Nexus 3, Nexus 4, port channel of 6. Right?
That is true.
Right? That's it. Yeah. And then you put the port channel on the top. Can you go to the back of the diagram again? The diagram that you just showed me? The diagram. Yeah, 1 second. Yeah. So you configure the port channel on the downstream devices.
I will share these nodes to you. Don't worry. Okay. You can go through those nodes. And if you have any sort of question, you feel free to ping me over the WhatsApp. Okay. Now, please excuse me because I need to go for another batch. Okay. I am really
sorry. You just create port channeling on the downstream devices 3, 4, 5, 6 servers, and then you create the VPC number 3, 4, 5, 6 on the Nexus switch on the upstream devices.
Right.
That's it.
Right.
Okay.
That's it.
Okay. So do you have any nodes for the pure gateway, the pure switch, delay restore?
I will share those nodes. Don't worry. I will share those.
Okay. Can you please send it to my email ID?
Yeah, for sure.
Okay. So that's it. That's VPC, right? Simple.
That's the VPC. Yeah.
That's it.
But there is a lot of more things, Rishi. We cannot say that it is the only thing. Okay. There are a lot of things. But since you only asked for 30 minutes or 1 hour of session, so we can conclude only these things in 1 hour. Okay. But there is hell lot of things in the Nexus. But that's all right. I hope you got
I'm talking only about VPCs. I already know VPC, VPC, and FEX and VXLAN. I know that. So, yeah.
Fine. Then it is the one
basic VPC. Only basic operator VPC. Right.
Right. Okay, then
Can you go
have
about the
a
diagram again?
have
Just
a
1 second.
very
Just 1
great
minute.
day. And if you have any doubt, you please